Direct variations. It is represented by y is equal to kx, wherein y and x here are the two quantities, and this tells us that y is directly affected whatever the values of x. As the x increases, y also increases. If the x decreases, y also decreases with a given constant rate represented by a variable k. Okay, so we need these skills in solving word problems involving direct variations. The translation of a verbal statement into a mathematical statement. So we have a given y varies directly as x. It is translated into y is equal to kx, and this is our variation. Y and x here are the two quantities, then k here is the constant. Given m varies proportionally as n, so it is translated as m is equal to kn. M and n are the two quantities, k is the constant. The shadow s varies directly as the height h of the object, so it is translated as s is equal to kh, where s is the shadow, h is the height, and k is the constant. Number 4, the distance traveled varies proportionally with the time spent in driving. So in this case, a variable is not given, so we're going to think of any variable, but we need to identify first where are the two quantities here. So it is the distance traveled and the time spent in driving. So for the distance, we can use a variable d to represent this quantity. Then for the time, we can use a variable t. So our variation is d is equal to k times t, or the distance is equal to the constant times time. Okay, so we need these skills in solving a word problems later on. Okay, the next skill that we need to develop is solving variations. So the given y varies directly as x. If x is 2, y is 10. If x is 7, find the value of y. So first, we're going to set up an equation from the given first sentence. So we have here y, and this is the equals, and this is our x with our constant, and we're done with our variation. Y is equal to kx. So next step, we're going to find this k using the same variation, y is equal to kx. Since this quantity y and x here, they are available in our first set of given, wherein x is 2, y is 10. So to substitute x is 2, y is 10, we can now find the value of k. So to isolate k, divide both sides by 2. Simplify this one. 2 divided by 2 is 1. 1 times k is k. 10 divided by 2 is 5. So our k or constant is 5. And lastly, we're going to find now the unknown. And that unknown is this y. What is this y? If x is 7. So to obtain that, we will use the same variation y is equal to kx, wherein our k here is 5, then our x here is 7. So our equation is now y is equal to 5 times 7, and 5 times 7 is 35, and this will be our answer. For the given number 2, so s varies proportionally as h. If s is 20, h is 5. Find h if s is 60. So step 1, we're going to set up a variation. So that variation can be taken from our first sentence, s varies proportionally as h. And don't forget the constant represented by variable k. So that will be our variation, s is equal to kh. Next, we're going to find this k, the constant, given this one, s is 20, h is 5, using the variation s is equal to kh. Substitute, h is 5 and s is 20. Then we want to isolate k, divide both sides by 5, and k is left, 20 divided by 5, 4. So our k is 4. Lastly, we will find the unknown h. That one. So what is this h if s is 60? So using the same variation, so since s is given, so we will replace s by 60, and we will replace this k by 4, so that we can find the value of h. We will divide now both sides by 4 because we want to isolate h. Then 4 divided by 4 is 1. H is left. 60 divided by 4 is 15. And our h, which is the unknown, is 15. Now, how are we going to apply this in a real-life situation? So we're going to apply the skills that we've learned a while ago. The shadow of an object S varies directly as its height h. A man 5 feet tall casts a shadow 20 feet long. If at the same time a flagpole casts a shadow 60 feet long, how high is the flagpole? So let us sketch our given. Okay, so this given is not, this sketch is not drawn to scale. So let's say we have here a man which is 5 feet tall. So let's assume that this man is 5 feet tall. It casts a shadow 20 feet long. Okay, I know that the shadow is a little bit smaller, but let's assume that this is a very long shadow, 20 feet long. If at the same time a flagpole casts a shadow which is 60, how high is the flagpole? So this will be our problem. What is the height of this flagpole? Okay, so we're going to apply the skills that we've learned a while ago. So it's the same process. First, we're going to set up a variation from our first sentence. S, the shadow of the object S, varies directly as h, then with a given constant k. So that is our variation. S is equal to kh. Next, we're going to find the constant using the same variation. So what are the available given here? So this 5 here, this is the height. And this 20, this represents the S, which is the shadow. So we'll just replace it. S is 20. Then H is 5 from here. Then we want to isolate K, divide both sides by 5. And finally, K is 4. Now, for our final step, we're going to find the unknown. What is the unknown, by the way? It is the height of the flagpole. And what is our available given? Our given here is the S. And that is the shadow of a flagpole. Okay, so using the same the same variation, S is equal to KH. So our S here is 60. And our K is already obtained, which is 4. Then we can now find the H, which is the height of the flagpole. Okay, so to isolate H, we will divide both sides by 4. So H is left here. 60 divided by 4 is 15. So to answer our question, how high is the flagpole? Our answer is the height of the flagpole is 15 feet long.